Welcome to how to create the Vim logo in Vim. So the basic idea is to create an indexed BMP file in hexadecimal notation inside Vim and convert that to binary, giving us a valid BMP file that we can view. Now, what does it mean to have an indexed BMP file? It means we don't have three color values, 3 color bytes per pixel. Instead, we have 1 byte per pixel, which just has an integer, basically, a number. And then we have a table which maps these numbers to actual color values. So the first thing we need to create is a color index of all the colors you want to use. Then we need to create an indexed picture, so basically just the indices instead of the pixels. And then we need to embed this into a BMP header, and last but not least, convert that to binary. Dependencies, if you want to follow along, we need XXD, which is a tool to convert something to hexadecimal representation and back. We need an image editing software like GIMP or similar, which we can use to read color values from pixels. And obviously we need Vim. So let's get started. I downloaded a 16 by 16 pixel Vim logo from the Vim homepage. And as you can see, we have some transparent pixels here. We are going to treat them as black pixels in order to not have to deal with transparency. So let's make some document where we can write some stuff down. Let's call that vim.text. So let's make our color index. First of all, let's use black. Black will get the index to 0, and let's just call it black for now. Next, let's take this gray color right here, which will get index 1, so let's call that light gray. Index 2, let's take the dark gray here. Index 3, let's take the white pixels here. Index 4, well, what's left? We have 2 colors, two greens here. So let's take the dark green first. This is going to be index 4, dark green, and then we have 5 for the light green, and then 6 for this one blue pixel here. Now we also need the RGB values of these colors so that we can map them, basically. So let's have a look at those. Let's get the color chooser here, and let's have a look at this. This is just all zeros, all black. Then our light gray is C zeros. So C0, C0, C0. Our dark gray, which we have here, is 80s. So 80, 80, 80. Then we have our white, which is just our standard white. We have our dark green, which is an 80 in the green byte, so 008000. And then we have a light green, which is just the full green, basically. So that is 00FF00. And last but not least, we have our blue pixel, which is 80 on the blue byte. So 000080. Now that we have that, let us recreate this picture here by using the indices of these colors. So in order to do that, let's first of all make everything black. So 1, 2, 3, 4, 5, 6, 7, 8, and one more time, that's 16 zeros, and let's just copy them and paste them 15 times. So we have our zeros. And what we do now, we can see pixels are 0 indexed here. So pixel number 7 going 7 to the right, 7 to the right. This pixel is light green, which is 5. And then we have this pixel across, which is dark green, which is 4, I think. Yep. So this is 4. Then we have this one across, which is dark gray. So we go down and left, and this is dark gray, which is 2. And we just continue like that with the whole image. So once we're done with that, it should look like that. And we can actually see that this is our Vim logo by searching for the 1, and we can actually see it prints Vim, which is kind of cool. So those are basically 1 digit per pixel. What we need for the bitmap is 1 byte per pixel. So if we think of these digits as hexadecimal digits, then we have 2 hex digits per byte, and the higher order byte will always be 0 because we only have stuff from 0 to 6 here. So what we need to do for all of those is we need to prepend a 0 and append a space. Let's do that. So we make a substitution. We want a capture group. We capture a single character. That's not a capture group. We capture a single character and replace it with a 0 the captured character and a space, and we want to do that for all the characters. So there we go. This is our basically byte array, and let's just get rid of those. So those are our bytes. If we now look for 0, 1, we can see it still says Vim, which is cool. So with that out of the way, let's start creating our bitmap file. We are done with GIMP, so let's close out of that. And let's get the Wikipedia page on the BMP file format. And there's the file structure and specifically the bitmap file header. Let's have a look at that. So what we're doing right now is we have a file, let's call it vim.hex, where we will write all the bytes. We'll write all the bytes in hexadecimal notation, and then we'll use xxd to convert that to a binary file. So there's first of all a bitmap file header, which just contains some basic information about the file. And it starts with the bytes 42 and 4D, which is just BM in ASCII. So BM for bitmap. So let's write them. That is 42 and 4D. So we're going to write 16 bytes per line. So let's just continue. Okay, next is a 4-byte value, which is the size of the whole file. We don't know that yet, so let's just use question marks here for now. We will fill that in later. That's 4 bytes. The next 4 bytes are reserved for the application that creates the thing. That is us basically. So let's just keep them at 0, 1, 2, 3, 4. And there's the next byte. Next 4 bytes are the offset address where the actual image data, the pixel data, starts. 4 bytes, we don't know them yet. So let's make them question marks as well. Now there's another header in there because remember we didn't define the colors, we didn't define the size of the image yet, so we need some other information. And this is called the bitmap information header, or the DIB header. And there's quite a few variants of this, but we are going to use the most common one, which is the bitmap info header, which is 40 bytes long. This is the bitmap info header, and it starts with the size of itself. So basically a 40 in hex, which is 28. Yeah, and that's one important thing which we need to consider now, and that is that the whole thing here is little endian, meaning, yeah, let's explain that first of all. So if we usually had the hex value 28, we would write that as 0x28, right? Simple. Now we have that as a 2-byte value. Well, we would prepend 2 zeros and write that as 0x0028. That is so-called big endian. Now little endian flips the thing around. So that would be 2800. The smaller part of the number comes first, and then comes the larger part. So that's why we have to write not 0028 here, but 2800. Okay, let's continue with the header. We have the bitmap width in pixels, which is, we know that as 16 pixels, or in hex, that is 10. And this is a 4, oh no, sorry. The size of the header was actually a 4-byte value, so we have to add 2 more zeros here. Now we have our width, which is 10, and that's 4 bytes, so we're here. And the height is also 10, so 16 pixels. Next one is a 2-byte value, which is the number of color planes, and which must be 1 in little endian, so we have 0100. And the next one is also a 2-byte value, which is the number of bits per pixel, which we're going to use. So usually if you have just an RGB, you have 24 bits per pixel, so 8 times 3. And we could basically use just 4 because we only have 7 colors. But we're going to use a single byte here in order to make our life easier. So let's put in 8 here. That is a 4-byte value again. Yep. So this is 08000000. Oh, it's not. I'm sorry. It is a 2-byte value. Next one is the compression method being used, and that's a 4-byte value. So we don't want to use any compression, so let's make that 0, 0, 0, 0, 0, and next line 0, 0, 0, 0. Great. Then we have the image size, so the size of the raw bitmap data, and we actually know that. That's 16 times 16 in hex. Let's just check that. Should be 256. So just to confirm that. Okay, and then we have the whole thing in hex, so we can use printf to do that. Let's say we want a hex value and a new line of 256, and that gives us 100. That's the number of pixels, the number of pixels, and thus the number of bytes that we have in this thing. So remember little endian, if we have, it basically looks like this, and we need to swap things around. So this is 00010000 as a 4-byte value. Next, we have the horizontal resolution of the image in pixels per meter. We just looked that up here on Wikipedia. There's an example, and it gives us the value for 72 dpi. And it is in little endian already 130b and then 0. So 130b 0000, and the same for the vertical one, 130b 0000. Okay, now back to our header. Next thing we need is the number of colors in our color palette. So now we come to the color palette definition. And yeah, we have, I think it was 7. Yeah, that's 7 colors. That is a 4-byte value. So let's set this to 07000000. Next one is the number of important colors. And all our colors are important, so we are just going to set this to zeros. Okay, now we need our color table. Color table is described down here. Each entry of the color table has 4 bytes, but they are not in RGB order, but they are in order, well, in reverse order basically. They are in order BGR and then the alpha value. So let's start with color 0, which is just black. This will be for 0 bytes. Next is light gray, which is C0, 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 and then an alpha. Then we have dark gray, which is 80, 80, 80, and zeros. Then we have our white, which is F, 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 0. Then we have our dark green, which is 0, 80, 0, 0. Then we have our light green, which is 0, F, 0, 0. And then we have our blue, and this is the only one where we need to pay attention to the order of bytes here. So this is not, we don't start from the left, we start from the right. So this is 80, 80, 0, 0, 0. So what follows now is the image data. So the stuff we have down here. So remember, if we search for 01 here, we get Vim. And it's in the correct order, basically, for us. Problem is, the BMP file format reads from, or rather stores things from bottom to top. So we need to reverse this image, basically flip the y-axis, and we can just run this through tag, and this gives us this image. And let's paste that here. Let's get rid of that. Okay, now we basically just need to bring that into 16-byte groups. So in order to be able to see what we're doing better, let's just write an X here. We need to basically remember this position for later. So let's first of all join the first line here and cut it at the 16th bit and get rid of the extra space here. Okay, and now let's just make that one big line and record a little macro so that we say we want to go 16 words to the right, and then we want to make a line break, and we just continue doing that. Now we are done with our image data. If we search for 01, we can kind of read Vim. We can see the V there. Now we need two things. We need the address where our image data starts, and this is this one. This is why I put the X there. And in order to better see the address, let's actually write the addresses here. XXD needs that anyway. So let us go here and write 8 zeros. 1, 2, 3, 4, a colon, and a space. So that is the address format of XXD. So those are hexadecimal addresses. We have 16 bits per line. So if this is, well, if this is byte 0, then this is byte 10. So let's put 1 here. This is 20, 30, and so on. Now we don't have 100 here. Remember, we're in hexadecimal. So this is A, B, and so on. Now we have our ones here. Okay, and now we also know the size of the file in bytes, which is 151. So we can put that here. What comes first is the 51 part. So 51, then 01, and the rest is zeros. And the offset, which we have here, now I can just see what that is. That is 5, 2. is where the first pixel starts, basically. So that is 5, 2, and the rest here is zeros. Now this should be a valid bitmap file if we convert that to a BMP. So let's do that. Let's use xxd, give them our vim.hex file, and write that to, oh no, we should specify that we want to reverse the whole thing, so -r. And let's write that to vim.bmp. Now let's open that. And let's turn off anti-aliasing. And there's our Vim logo created in Vim.